So here we want to find the volume of a solid by revolving the region bounded by the given line. So to start out, we are given that it's going to be the functions e to the x, y is equal to 0, x is equal to 1, and x is equal to 4. And these are our bounds for the region. So I'm just going to kind of draw out what this thing's region is going to look like. Then we're going to take this region and we're going to rotate it about the x-axis. This is going to give us the volume of our solid. Well, how do we find a volume? Well, we're going to add up several different smaller disks. Let's say these little disks are going to have a width change in x. This means that our change in volume, but let's think for a moment. So this is going to be like a disk going all the way around the x-axis. So it's going to look something on the lines of this kind of bad drawing here, but that's okay. I'm not Picasso. It's going to have a height of change in x, and the radius is just going to be the y value of the function, which is just e to the x. But it's going to... So we know the radius, and we know the height, change in height. We know a formula for a cylinder is V is equal to pi r squared times by height. So then our little change in V's that we're going to sum up to get the total area is going to be pi times by e to the x squared. And then our height is change of x. Now we just have to put this into the integral form, which is going to be the integral from 1 to 4, as that's where we're bounding the area. E to the x is the same thing as e to the 2x, so we get e to the 2x. I pulled the pi out front, and this change in x becomes dx's, as we're going to be adding infinitesimally small widths to find the total volume to an accuracy. Well, what's the integral of e to the 2x? That's just going to be 1/2 e to the 2x times by pi, evaluated from 4 to 1. Plugging in 4, we get pi over 2 e to the 8th minus pi over 2 e squared. And that is our solution to the volume for revolving e to the x around the x-axis from 1 to 4.